Hello students, this is Mrs. Denton and this will be our first video of the year. You should have this worksheet blank, and what this is just a list of all of the basic geometric figures that we're going to learn about. I've already gone ahead and filled in the notes, and what I'm going to do is cover up a row at a time and talk about the object. I think what this is able to do for you is you'll be able to copy down what I've already written at your own speed. You can also pause the video at any time if I'm moving too fast, and you can re-listen to what I have to say. Also, that way my hand won't be in the way while you're trying to write. So our first figure here is a point. A point is a random location in space. It has no length, it has no width, it has no depth. In fact, it has 0 dimensions. If you think about a point as a location in space, I think it makes sense if I say, I'm going to room 253. That's my room in our school building. It's representing a location. If we were to put that on a map, we could put a point on the map to represent where we are. So a point is a location. When we write down a point, the notation is represented with a dot on a piece of paper, and it's named with a capital letter. Now, that dot does have some dimension. It's a little tiny bit wide, it's a little tiny bit tall. We could measure that circle on the piece of paper. However, that's just a representation. In fact, there would be no way for us to see something with 0 dimensions. So our first figure is a point. Remember, pause if you need to continue writing. Our next figure we're going to talk about is a line. A line is a collection of points that are all strung together, and they extend infinitely in opposite directions. That's what makes them straight. So just think of this as a whole bunch of points all clustered together in a straight path. That's a line. A line only has that one dimension. It only has length to it. It has no thickness and it has no width. Again, I know you could look at our picture and say that this has some kind of thickness to it. In fact, in Word, I could change the thickness of this line, but that's just a way to represent the image on paper. It only has one dimension, and that is the dimension of length. When we write up a line, we use any 2 points on the line. Here in this picture, I have the point A. There's that capital letter and a little dot A, and the point B, the capital letter, little dot B. These are the 2 points I've designated on this line. You can use them in any order as long as you have the double arrowhead on top. Another way to designate a line that's not as frequently used is with a lowercase script letter. I've put a cursive M on this line, so we could also call this line M. Remember, pause at any time. Our next figure is a line segment. A line segment is just a part of a line that's defined by the 2 endpoints. So these 2 pictures are similar, but here this line does not continue forever. It stops at point A and it stops at point B. It only has one dimension, and that's the length. We could measure how long this line is. So a line segment is just a portion of a line. It's a part of the line. The way we write it is we use those defined endpoints. So it can't be any 2 points on the line. It has to be the beginning and the end. Now we could say A is the beginning and B is the end, or we could say B is the beginning and A is the end. It really doesn't matter. But we use the 2 endpoints. Also notice the notation above the capital letters has no arrows on either side. These are defined endpoints, so there's no continuing arrows. All right, our next point to talk about is the length of a line segment. Okay, we talked about the object, the line segment, and now we're going to talk about the length. I've used the exact same picture. So this is a line segment. However, now I want to talk about how long that line segment is. The length of the line segment is the distance between 2 points. I have this protractor here, but I'm going to use the ruler edge, and I can measure this line segment to be 2 inches. Okay, so the length of a line segment is the distance between the 2 points. I could use inches, I could use centimeters, I could use feet if it was a really big line segment. We could use miles if we're thinking about the points representing location. The distance from Salem to Roanoke may be measured in miles. But when we're talking about the length of a segment, we're talking about the distance between the 2 points. Notice over here in our notation, there's no segment symbol over top of the letters. Okay, that's the designation between the object, the line segment, and the length between the 2 points. Our next object here is a ray. Our last one on the front of this page. An array is sort of a line and sort of a line segment. It has one defined point, and then it continues in one direction infinitely. It has one defined endpoint and extends infinitely in one direction. Well, that endpoint makes a difference in our notation. I've listed x first because x is the defined endpoint, and then I've listed y second, and that could be any point on the ray. If we had another point designated here, and we called it z, now this could be ray xz. Okay, remember to pause at any time. I'm going to get my next sheet. Okay, this is just the back of your notes here. And now we're looking at the figure, an angle. An angle. An angle has kind of a funky definition. You got to be really careful what we're defining here. The angle is the space, that's usually measured in degrees, with our old-fashioned protractor here. It's the space usually measured in degrees that's formed by 2 lines or 2 rays that diverge from a common point called the vertex. Now that's a really fancy definition, so let's break it down. An angle is this amount of space. It's the amount of rotation or the amount of turn between these 2 rays. We have this ray, AC, and we have this ray, AB, and they're coming out of this common endpoint down here, A. That's the vertex point. It gets a special name. So we've got 2 rays that come out of the vertex, and the space between them is the angle. It's funky, huh? All right, well, there are 3 ways to name an angle. You could use all 3 points. I could start at point B, go down to the vertex A, and then go out to point C. So this could be called angle BAC, the angle symbol out front, and then all 3 capital letters designating the 3 points we're using. Or we could start here at C, go to vertex point A, and then out to point B, and call it angle CAB. Either way is correct. Notice that the vertex point has to be what's in the center of the angle. For this particular picture, which is a very simplified angle, we could also just name this using the vertex point. So we could just call this angle A. We could also call it angle 4. This is not 4 degrees. Let me get my protractor again. 4 degrees is teeny tiny. Okay, we'll talk about how to measure an angle at a later date, but 4 degrees would be teeny, teeny, teeny tiny, so thin. So this angle is much larger than 4 degrees. I have named this angle 4, and that becomes a really simplified way to name an angle. So you've got 3 different ways to name an angle. Remember, pause at any time. Our next figure here is a plane. A plane is a flat two-dimensional object that extends in all directions infinitely. We often use like a piece of paper to represent a plane. Here's a two-dimensional object. It's got width, it's got length, okay? A regular old piece of paper could be a good example of a plane. However, a plane extends infinitely, whereas a piece of paper stops. So we're looking for a flat surface that just continues forever and ever and ever. This is our first two-dimensional object. This object has length and width. A plane can be measured in 2 ways, noted in 2 ways. You could use any 3 non-collinear points to name a plane. Now, non-collinear is a fancy word that means any 3 points that are not in a straight line. So over here I've got point A, B, and C. Okay, they're not in a straight line together. And these 3 points can be listed in any order to name the plane. So I could call it plane ABC, or plane BCA, or plane CAB. Any 3 non-collinear points will name a plane. We could also name it, and this is a little more rare, but we could also name it with a capital script letter. Now that's my big capital cursive L. Capital L in the corner of this plane. Okay, guys, just a few more to go. Next, we're going to look at the concept of congruent segments. The word congruent just means the same or equal. So congruent segments are segments of equal length. Now over here in my picture, I've got this notation here I'm highlighting in yellow. That is a notation that you can add to a picture that symbolizes congruence. Aren't you happy you didn't have to watch my hand the whole video? Symbolizes congruence. So we can say segment AM is congruent to segment MB. This symbol over here, it's not a mistake. It's an equal sign with a squiggly over top. That is your symbol for congruent. So here we're saying that these 2 objects are congruent. These 2 objects are the same. If we only used an equal sign, then we are saying that 2 values are equal. We can't say 2 objects are equal. We can say 2 objects are congruent. We can say 2 values are equal. So I've taken off the symbol for a segment. This says the distance from A to M is equal to the distance from M to B. So there is a difference between the symbol for congruence versus equality. Our very last object down here, our last concept, is congruent angles. Okay. Again, there's a special symbol you can use in a picture to represent congruent angles, and it's this arc added into the angle. Remember, an angle represents the space between 2 rays that come out of a vertex. So here we have 2 angles of equal degree measure. Congruent angles are equal degree measure. And this symbol added into the picture represents congruence. Okay, pen looks like it's dying a little. Okay, and just like with segments, we have to make sure we understand what we're saying when we're using this symbol for congruence. We are saying that the object, the angle ABC, is congruent to the object angle DEF. Those two angles are congruent objects. If we use the equal sign, we're saying something different. We're saying that the measure of angle ABC is equal to the measure of angle DEF. We'd have to get out our protractor and measure these two angles to say that they had an equal degree measure if we were using the equal sign. If we're using the congruent sign, then we're saying that the objects are congruent to each other. Thank you so much for watching this video. I hope you learned something. If you're confused about anything, come see myself or come see Coach Holter and we'll help you out. And please feel free to re-watch it if you need to. Have a great afternoon. Thanks.